Okay, so this last question here, a gas is collected over water at a pressure of 98 kilopascals. It occupies a volume of 596 centimeters cubed at 80 degrees Celsius. What volume will the dry gas occupy at 43 degrees Celsius and standard pressure? So again, let's outline all of our variables. So I have P1, V1, and T1, as well as final conditions, P2, V2, and T2. We're looking at T2 being 43 degrees Celsius, 80 degrees Celsius. The volume is 596 centimeters cubed. Pressure 1, 98 kilopascals. And we're talking about standard pressure. So again, because we're dealing with kilopascals, that's 101.3 kilopascals, and we're solving for the volume. So a couple things that we have going on here. Remember, we need to convert from degrees Celsius into degrees Kelvin. It's not constant this time, so I can't just cross out my temperature. So 80 degrees would really be 353 Kelvin, and 43 would be 316 Kelvin. Then I need to look at my pressure. Remember, I said that in terms of these questions, if you see something asking you for dry gas, then chances are you need to account for that water vapor. So pull out your water vapor. Again, I'm looking for the pressure at 80 degrees. So I can find that over here at 80 degrees. I have a pressure of 47.3. So then let's add that onto our question here. So minus 47.3 kilopascals. So my P1 is really 50.7 kilopascals. So now I can look at this question. I'm going to plug everything into my combined gas law. Remember, I can't cancel anything out, so I need to have all of my variables. So combined gas law is P1 V1 over T1 equals P2 V2 over T2. So remember, we're using our dry gas. So 50.7 kilopascals. I have my volume. And I have my temperature in degrees Kelvin. And that equals my standard pressure, my unknown volume, and my temperature in degrees Kelvin. So remember, I said that when you're taking things over from the bottom, you're multiplying, taking things over from the top, you're dividing. So this would be 316 Kelvin on the top and 101.3 kilopascals on the bottom. So to make sure that I rearranged everything correctly, let's do some unit analysis. So Kelvin cancels out with Kelvin, kilopascals with kilopascals, left with centimeters cubed, solving for volume, so that makes sense. So when I plug everything in, these guys are gone. So my volume would equal 267 centimeters cubed based on my significant digits that I'm allowed. I'm only allowed to have 2 sig figs here. So I'm going to write this one as 2.7 times 10 to the 2 centimeters. Oopsies. Centimeters cubed. So here is my final answer.